may not have taken that. They may have come a different way. You know, like if you tested on your ACT in the college level, you could have come right here if you wanted to. So anyway, uh, okay, so let's look at that end of 2.2. This last thing was called piecewise functions. This is a little different than probably if you had the Math 097. This right here is kind of strange. And it's not strange in any kind of mystery way. It's just that it's so darn simple that it's easy to think, wow, what's going on here? But there's this thing called a piecewise function. And a piecewise function just means that it's going to be made up of two different equations, essentially, that are kind of tacked together based upon the domain. Whatever the domain is, you would use one of the other equations. So a good example of this would be something like, I don't know how Uber works, but, you know, like with the old taxis, generally, once you get in a taxi, you get charged a flat amount that's going to cover you for, I don't know, maybe a mile or two. And then after that, you get in charge per mile. So the way that you would calculate your rate, let's say if you were, let's say the flat rate covered 2 miles and you wanted to go 5 miles, well, you would pay whatever that flat rate is, and then for the next 3 miles, you would add on the extra mileage per minute kind of thing. So that's a perfect example of how a piecewise function works. All right. So you can also do it probably with a single function, but that's kind of what this is all about. Notice that what I'm showing you here it's called C of t, and sometimes what they use these for is probably cost and time. Usually, if you don't use F or G, sometimes they'll use a different letter, both for the F and the X, in order to specify things that are specific. Like in this case, it's cost and time. Okay. All right. So what this means is, if t is time, which I'm pretty sure it is in this case, they don't specify, but it's very similar to what I was talking about, like a taxi cab ride, except it's talking about time and not miles. But anyway, what it is, if the value of t, in other words, the input, like your x, is between 0 and 60, and notice that it includes the endpoints, then the flat rate is going to be 20, or the functional value will be 20. So if you want to calculate what C of 40 is, then it's just equal to 20. And that would be true for any value between 0 and 60. It would just pump out a 20 automatically. No calculation to do. You're just going by what's given there. Now, once it gets past 60, in other words, 61 and higher, then you just plug it into this function here, the bottom one. All right. See? So if they want us to have 80, C of 80, then 80 is the t, so it goes in place of the t, so that's why they put C of 80 is equal to 20 plus 0.40 times 80 minus 20. 80 minus 20 is, 80 minus 60. 80 minus 60 is 20. Since that was the function, the input value, it gets multiplied times the 40. and that ends up being 8. In other words, if you want to see it, sometimes I like to just do things here so you can see that the math is holding true. So there's the 8 that comes about right here. That right there is equal to 8, and then it gets added to 20. So C of 8 is 28. Okay? So, does that make sense? Any questions about that? All right. So let's look at this next one. Here's another one. All right. So this one is just plain old f of x. Yeah, I'm saying there's nothing should nothing be complicated about this. It just kind of throws people off because they have not seen it. You know, it's not the standard thing you cover in basic algebra. All right, but it's very applied, which this course is basically showing you things. For the most part, it's showing you things that are useful in various aspects of life. You know, things like science and business and such. All right, so here we got another one. F of x is equal to, and it's got two different possibilities. If the value of x is less than -1, then the output is just going to be 3. So in other words, it says less than or equal to. So basically, any negative number is going to, the output is 3. But if it's greater than -1, in other words, if it's 0 on up, what we call a whole number, then it can just pop in. That value just pops in place of x and you work it out. All right. So they're asking us to graph it. So let's see. Notice that what they do, and whenever you graph by hand, it's kind of almost, you basically get to pick whatever point, but they pick them for us here. They pick the -1, -2, -3. And notice that all of those things are 3. This is what we call a constant function. In other words, the y is always going to be 3. All right. And I got a little thing over here I can show you. It's a neat little tool, graphing tool. Let's see, there's a way to do the range here. Let's see, it said so it's less than or equal to -1. All right, that's 3 now. One. So it's not putting in that range. I never tried to do a piecewise on here. I thought it might work. Oh well, let's scratch that and just go with the one on there. That's a neat little graphing tool, but I've never done a piecewise. So they're going to show you on here. All right. So then after we get above the negative numbers, now this is not, something's not right here. See, it says less than or equal to -1, and then they put -1 in there and calculate it out, and that's not right. Because it's greater than -1. Let's put something else there. So if I put in 2, we would get 0. There we go. So anyway, that's just something I just noticed. It says less than or equal to -1. So it includes -1. And this one's greater than -1. So it would be 0, 1, and then 2. I just kind of got the order a little bit off because I had to replace it. All right, so what does that look like? Well, this is what it looks like. Y is equal to 3. Then anything -1 and below. And notice that there's a hole, I'm sorry, that there's a solid point on the end of this right there. Because remember, that's because of the equal to. That's why I changed that little thing there that was wrong. All right, and notice that on the other end, and that was one of the things I couldn't figure out how to do on that Desmos graph thing, is to just get it to be going all the way down on the infinity. That arrow there on the left for the f of x is equal to 3 is going all the way down to infinity there. All right, now here's the other part, and this is why I changed that thing, because at 1, you've got a hole on the other side, because 4 x is equal to -1 is 3. But anything above -1, in other words, it could be a very, very, very close value, and it would be like negative 0.9999999. It gets very close, but never gets to -1. Anything that's above -1, I'm sorry, not negative 0.999. No, it is. I'm sorry, it's negative 0.9999. It works the opposite way than it does on the positive side. That's one of the things I try to tell students in my 097 class. On the negative side, it's like bizarro world. Everything's the opposite. All right. Well, anyway, so just above -1, see, it starts turning into this line of x minus 2. And x minus 2 is what we call a linear equation, that it's just a line. Now, this is a line too, but it's what we call a constant line. It doesn't change along the, it's a horizontal constant line. It doesn't change. But this one has a slope of 1, because that's what's in front of the x. And it's just going up and up and up. And again, it's got an arrow on the other side. All right. So like I said, that's about all there was to this. So to finish out 2.2, that's all there was. If you got any questions, if it's not clear, I'll try to fill in the blanks. All right. Hold on a second. I got one of those fellow students is out there saying they can't get in. Let me just tell them the options. That's not even coming in, is it? All right, and one of the things that I think it was you folks that were saying that there was some of the videos were, and I think I finally figured out what was going on. All right, there were multiple videos getting made, because I didn't realize this. I was letting people, I had to let, for the sessions, I was letting people go into the class before me. And what it does is it creates a video of that. So for however long that somebody's in there, until I get there, it would create a separate video. So anyway, I turned that off so that you have to come in after me. And so it should be just creating one video. And I'm going to, and it takes a couple of hours, I think I told you this, for it to get processed after the class. And when that happens, then I can share it. and you should be able to open it. Now, if it still creates a problem, then I'll just can upload it to YouTube or something. But it should work because I think what it was just a bunch of different little videos in there that there was nothing inside of them anyway, even if you could open them.
Sometimes it asks for a password.
Right, and I mean that's the thing is, and I can show you is don't have a password for you to get in the class, but for some reason it wants me to until I share it. See, I'll just show you. There shouldn't be a password, so I was just going to show you here. Maybe there's something I don't quite understand, but anyway, when you share it, see, I can turn off the password protection. So when I share it, I always do that. So if, let's just see if I can, because the password is not anything I put on it. So if there's a password, it's doing it on its own. And I don't know why yours isn't in there.
Sometimes it lets me through. Sometimes it asks for a password and I can't get into it.
But let me just see. Okay, use this. Is this us? Make sure this is us. I'm going to put this passcode in here. If it ever asks one, try that.
Okay.
I don't know why. I guess it is. This is strange. I'd have that turned off, I thought. Anyway, because I don't know how y'all would get in without a passcode. Like I said, this thing's got a mind of its own, I think.
Kind of quirky.
Something I don't understand. The system that I used when we first started doing the the virtual classes was built into Canvas. It's called Big Red Blue Button, and it worked great. But then the school, somehow everybody started using Zoom, so they started paying for Zoom and get away with that other thing. So it's got more stuff, but then there's more things you got to figure out how to do. All right, so let's look at 2.3. All right, 2.3. Like I said, most of this is technically review from our 09-7 class, but I'm going to try to talk about all of it, and I'll concentrate on the one things that are technically in the class. All right, so technically this isn't covered, but it's expected that you know it as a prerequisite, so I'm going to just kind of briefly go over it. But that's the definition of the slope, all right? The slope of a line is just a measure with one value. It could either be positive, negative, fractional, and it tells us how quickly or how steep the upslope, well, I hate to use the word slope in the definition of slope, but it just tells us how, what the, let's go back to this one over here. See, like this right here, that's the slope right there. So if this thing were to move back and forth, like pivot along that circle thing down there, the slope would change because what it is, it's kind of just how fast or how quickly it's going up, or it could be going down based upon moving left to right. All right. So that's what slope is talking about. All right, so let's just look at a quick calculation. So let's say you got 2 points. They use in the function definition. In other words, in the formula, they use the x1, y1, y2, x2, y2, meaning that you got to have 2 points. Now it doesn't matter which one is point 1 and which one is point 2. Usually it's kind of do them in order, but sometimes you can switch them around. But you got to make sure that you keep the same point. You can't switch in midstream. In other words, the point 2, both of them have to be x2, y2. And point 1, they both have to be x1, y1. But you can pick the second one as your first point, and the next one as your first point. So like this. All right. See, they give us 2 points. They don't label which one is x2 and what, I'm sorry, 0.2 and which one's 0.1, but they're going in order. So they're calling this 0.1 and this 0.2. Now, what I would do when I'm working these, because I have a tendency to scramble them up in my head, especially if I'm in a rush, I would just like write down here x1, y1, x2, y2, and then just fill in the blanks. So y2 is 5. In other words, the y coordinate from the second point right there, minus, that minus is built in. So if this point, which is y1, is negative, see, it goes in there, and then it's going to counter with that other negative, and it's going to make it a plus. So 5 plus 2 is 7. And then down here, it's the x2, which is the negative 1, minus the minus built in, and then the 4. So that's minus 5. So negative 7/5. And then in case you don't remember or never was told, if you got one negative sign, whether it's a numerator or a denominator, it just means the whole thing is negative. So usually the simple place to put it is right out in front. It means the same thing. All right. All right, now this is the one that they want us to stress here. All right. So if we want to create an equation, and we do go with this in 097, but this is part of the course here. It's something we're supposed to spend a little bit more time on, and I expect you to know. But this is what we call the point slope form of an equation. And what this essentially means is if we've got the slope of a line, that's a slope, and then we have a point on that line, we can create an equation for it. All right. So the way it works is you got the m, which is your slope, and then you got one point. And so the way it works is this is the variable, stays in there, minus whatever that number is there is equal to m, and that's going to be your slope, and it's multiplying in parentheses the x minus whatever that point is there. And then you go ahead and simplify it, and then you can write it in a couple different ways, however you ask to write it. So we'll go through one or two. Now the other thing, well, here's one, and then we'll look at it in detail here. But they give us a slope of 6, and they give us a point of 2, comma, negative 5. All right? So then what we're going to do is just fill in this thing here. So that's y minus, and it's a minus 5. So again, you got to account for the fact that that negative sign is built in, and the point there is negative, so it's going to end up being plus here. All right? Then you got 6 times x minus, and it's at 2. So 6 times x. Well, I'm sorry, they don't do it till down here. But anyway, then they simplify the negative and negative to get the y plus 5 is equal to 6 times x minus 2. So this is what we got. Now, usually you're not going to want to keep it in that form. You'll put it in one of two forms, usually what they call the y is equal to mx plus b format. In other words, you solve it for y. So what you got to do is you simplify this part. 6 times x is 6x. 6 times negative 2 is negative 12. And then the plus 5, you subtract 5 from 12 to get y is equal to 6x minus 17. And that's what we call the slope-intercept form. All right, y is equal to mx plus b. And what's good about this is for graphing purposes, or just to give us some characteristics of that line. This means that at negative 17, this thing crosses the y-axis. So that right there, in this case, is your b, and then 6 is your slope. I'll show you. All right, so here we go. This is that line. And like I said, it crosses at 17. Oops, was it negative 17? Did I write it right? I thought it said 17. No, it was negative 17. I'm sorry. So it crosses at negative 17. I think I told you 17. But it's negative 17. You take the sign with it. So see right there? That's negative 17. That's what we call the y-intercept. And then this slope is 6. In other words, what that means is for every 6 hops upward, 1, 2, 3, 4, 5, 6, there's a movement on the on the x-axis in the positive direction, 1. So the slope, you could read it as 6 over 1. So that's what they call rise over run for graphing. So rise 6 because it's positive, and then positive 1. Now, one of the things about drawbacks of this y is equal to mx plus b is it doesn't tell you at a glance what the x-intercept is. You can find it, but that's for another. We'll see in a bit. They got something called the standard form if you want to find the y-intercept. You can also find it here. What you would just do is you would just set y is equal to 0 and then solve it for x, but it just takes a little bit more work. But incidentally, that's all it means. Does anybody want to see another example on that? I can do one out on the board if you want.
Yes, that's fine.
All right. Let's see here. I'll have to make one up. Sometimes making them up, they're not as pretty. But this is what I was telling you here. When it's in y is equal to mx plus b format, the b, the one hanging off the end, is your y-intercept. So that point would be 0, comma b, and m is the slope. And that's just basically what I told you there. All right, so let's come up with another one to work. Sometimes they'll put right, sometimes they'll put fine. Let me put m. Sometimes they may do this. Sometimes they say slope, but sometimes they might just say half and through. Let's see. All right. So write an equation of a line with slope 1/2 and through -2 and 6. Okay. So remember, this is what we're filling in. All right. So this is x1, y1. You only got 1 point, and of course this is m. If they had said slope, then you just realize that that's m. All right. So y minus 6 is equal to 1/2 times x minus, oops, let me back that up there, 1 minus 2. So remember, you got to account for that double negative there. So that's going to be y minus 6 and then we got to run it through here to distribute. One half times 2 is 1. All right, then we're going to put it in that y is equal to mx plus b format. So I'm going to add 6 to counteract that one to get it over here. These are gone. So y is equal to 1/2 x plus 7. So that what that means is that this crosses the y-axis at 7, or the 0.07, and it's got a slope of 1, 2. In other words, this is going to be, for every 1 it rises, it's going to run 2 in the positive direction. So let's just look at that. So see that? It's crossing at 7, but it's got now, it's not as steep of a slope. The higher that number, the steeper the slope is. Now also too, I'm going to do this real briefly. Let's just say it was a negative. And this will lead us into this right here is a negative slope. Notice it goes the other way. And also too, and this is a good thing to know, and it mentions it in here, but it's one of those things, again, they're using it as a prerequisite. They're not putting any detail on it. So 1/2 and -2 are reciprocal slopes. So points that, slope lines that have opposite sign reciprocal are perpendicular to one another. And also too, let's just say we had another one with the same slope. Parallel lines have the same slope. Okay. Anyway, let's go back over here. So this is just what I was telling you about graphing. All right. So this right here is the free point right there. That tells you where it crosses the y-axis. You use a sign. So 1 is where this thing crosses at. Now, it's a positive 3/5. So that means that we're going to rise 3 and then the denominator run. And since it's positive, both the rise and the run will be positive. So see? Rise 3, run 5. There's your other point, and you can see where it's at. It's, in this case, it's I think they got that backwards. It should be 5-4. Should be 5-4. Anyway, let me graph it over here and show you. I think it's messed up. But anyway, the rise and run is right. It's rise 3, run 5. Now, in the case where it ends up being a negative sign in front of the slope, there's 2 different ways to do it. But in order to stay true to the rise over run name, I would just rise and then run in the negative direction. It's 3/5 x plus 6. 3/5 x plus 6. No, it's plus 1, wasn't it? So just to kind of show you, and I can zoom in here, but this is why I like this. But it wouldn't say 1. All right, so here was the where it crosses the y-axis. So rise 3, 1, 2, 3, and then 1, and then run 1, 2, 3, 4, 5. See, and like I said, I think they made a mistake. Yeah, it's 5-4 because they show it as 4-5. See, that one's not on the line, so they got it backwards. So if they're doing that on the textbook, it means that it's easy for you to do it too. So learn from that, okay? They wrote it wrong. All right, but that's what rise and run means. If you want to stay true to the rise over run, like I said, you always rise what's in the numerator, and then you run in the direction of the sign. So if it's positive, you rise and then go east, however many's in the denominator. Now, if it's negative, you go rise and then you can go left, however much is in the denominator. But you can also think of it as you got one negative sign, so you could go down if you wanted to and use up your negative sign and then go go in the other direction positive. All right, and that's what I was talking about, a horizontal line. That line that we had in that piecewise function was called a horizontal line. Again, this is not, this is something they go around seven. We're not going to stress it too much here, but I'm going to recap it. That if you just have y is equal to something, there's not going to be a slope to it. It's going to be a zero slope because the x is zero. This is the same thing as saying y is equal to 0x plus b. So whatever whatever y is equal to, it's just going to be a horizontal line at that point. So let me just show you real briefly on the little graph thing, the two lines. So let's say we got y is equal to 4. So there's your horizontal line. All right, and there's your vertical line. And just kind of notice that what happens is, no matter what x is on the black line, on the horizontal line, y is always equal to 4. And this is what we call slope 0. In other words, it's a neutral slope, so it doesn't have anything. So if you imagine that this be like a ramp, these lines that we've been looking at, the slope tells us how fast it's going to go down in physics terms. On this one, that's like the floor of the horizontal, if you put a ball in there, it wouldn't, if it's assuming that it's a true flat surface, it's not going to roll anywhere because there's no slope. Now, I just mentioned about the vertical line. Those two things are perpendicular to one another. But this one right here has slope of undefined. All right. The vertical line, it's not that it has zero slope. It's not that it has no slope. It has an undefined slope. Undefined slope. I just thought of something. I wonder if I've accidentally pressed record to my computer. Because usually you see it on there. Let me just check on this. Record automatically, but it says to the cloud. I just don't know why I don't see it on there. Oh well, hopefully I'll do it. And end up being there eventually. Before the storm, I think it was, no, it was my Monday, Wednesday class. There was something weird happening. And it was like Wednesday before I'd sent out something that was doing strange. And then, of course, I didn't get a reply till, we started battering down the hatches. And I never got the questions answered. All right, and this right here is what's called the standard or the general form of an equation, a linear equation. So if it's in this form, you can solve it for y by solving for, by solving for y. So this is what we call the general form. And what's good about this, especially if you put the constant on the other side, you can substitute 0 in for x and 0 in for y and get some really many equations and find out what your x and y intercepts are. All right. So, but you can solve this for y and get in that form that we just looked at. So in other words, what they do is they bring the 3x over, make it negative, bring the 12 over, change the sign, and then divide everything by 6. And there you've got it as a y is equal to mx plus b format. And they're the exact same thing as long as you do the solutions correctly. It's just that most people find that putting it in the y is equal to mx plus b format is the simplest way to graph it. You almost have to do no calculations. Now, if it's not already in that form, you have to do this. You got a little bit extra stuff, but anyway. And as I was saying, is you can use the intercepts to graph as well, but it's calculated. So let me just show you what they're talking about. So if you want to find the x-intercept, you're going to let the y be equal to 0. What's going to happen when y is equal to 0? Well, negative 2 times 0 is just 0. So all you have left is 3x minus 6 equals 0. Solve for x, and so x is equal to 2. That's usually pretty easy to do on most of these that are in this general form. You can also do it with the y. All right. So if you want to find the y-intercept, you're going to substitute 0 in for x here. So that's going to be 0 when 3 times 0, or anything times 0 is 0. So all you have left is negative 2y minus 6 is equal to 0. Add 6 and then divide by 2. Now, one of the drawbacks of the way this author or this textbook does things, they use this thing they call the general form. In Math 097, even though it's using my math lab, it's because of the textbook author. They usually would put it like this in the other textbook and call it standard form. So just realize that that's the same thing. That's what we would call standard form if you were in 097 recently. But it's the same thing. You know, everybody, and this is one of the things about mathematics, it comes sometimes make it frustrating. But it also goes back to the fact that mathematics is like an art. You've got general rules that you follow. If you follow those rules, you can take generally different steps to get there. You know, if I was to give a problem for do, the how them will be unique. Now, if I follow in the basic math rules, it may not be exactly the same, but the final output should be the same. So x is equal to 2, which means 2 comma 0. And when they have 0 comma negative 3, they get that y-intercept. So y-intercept was 0 comma negative 3. X-intercept is 2, and you can put a line through it. Now, the drawback of doing it with this method is when you graph by points, it's really, really wise to throw in a random point, not a random point in that you just pull a plot point out of the air. You could put in any x point, any x value, and come out with a y that gives you a coordinate that's on the line. And that's always a good check because you can draw a line through any 2 points. So if you make a mistake on one of them, then it can be an issue. So let's see. Let me give you another one of those, and then we'll get into the last little thing we were going to talk about. Oops, that's not what I want. So let's say we're going to find So find the x and y intercepts for this thing. And I've got it in that standard form because that's really a little bit more useful to put it in there. Let's just put that little number over there. In other words, subtract that number. and then it'll almost make this a thing. So let me put the text. To find the x-intercept, let y be equal to 0. All right, so 2x plus 3 times 0 is equal to negative 12. So what you easily could have done is just wrote 2x is equal to negative 12, because letting that be 0 is going to just knock it out. It's no longer there, nothing there. The y terms are gone. So that's negative 6, 0. All right. To find the y-intercept, let x be equal to 0, just the opposite. And like I said, is just remember here is if you let x be equal to 0, this right here is going to be gone there. So if you're wondering why I'm only putting 3y is equal to 0, it's just I'm trying to simplify the process and show you that finding these x and y intercepts when it's in that form is a real easy matter, because you're putting 0 in there, so that term's going to go away. So then our y-intercept is 0, negative 4. All right, and so go back over and graph it. 0, comma, negative 4. And then what was the other one? It was negative 6, 0. So there's the y-intercept, here's your x-intercept, and so the line is going to be what's that? I must have wrote it down wrong. I must have remembered it wrong. 2x plus 3y, that's equal to negative 12. Yeah, negative 12. There we go. So there we go. All right, so let's look at this last little thing. It's an application, and like I said, that's the one thing in this section they want us to concentrate on. All right, so they're using data points, and oftentimes in real life, you know, points and equations, they're not going to be perfect rounded off numbers, you know, not whole numbers. Like usually what things that we use in like Math 097, most of the values are going to be fairly simple. But in real life, when you have things, they're going to be decimals and fractions and all those kind of things. So they ask us to use the data points 3, 17, and 57.04, 1 point, and then the other one is 354, 57.64, to get a linear function that models the average global temperature for atmospheric carbon dioxide concentration in parts per million. So in other words, we want to use those 2 points to create an equation. Now, they didn't give us a slope, so the only way that we can find a slope is to go through here and create the slope ourselves using the 2 points. And then what we'll do is once we get that slope, we'll come back and use one of the points, all right, to create the equation. So as I said here, this is x1, y1, x2, y2, x1, y1, x1, y1, x2, y2. So that's what they're doing. So in the numerator is the change in y. That's why the rise, that's the y. Rise is y. So y2, 57.64 minus, that's built in. This is positive 57.04. The difference between those is 0.6. And then the denominators are the x's, same order. x2, 354 minus 317 gives us 37. And then if you take 0.6 and divide it by 0.37, hold on a second, what did I do? 0.6, yeah, 0.016, okay? So that's a real, almost flat slope, but it's very close to zero. Remember that horizontal line has slope of zero. So this thing is, like 2/10, I'm sorry, 2/100ths actually. So the slope is very minimal. All right, so now we got that slope. So what we can do is just take one of the points, and it really doesn't matter. They took this one, the second one. You could use either one, same results. So we're using the form there that we got. So y minus the y coordinate is equal to m. This was that slope we just calculated, times, and you got to multiply both of those things. That's why it's in parentheses. X minus 354. See? So they're using that point there. And then just simplify it. So run this through here, and then add that on to get it on this other side. So then here's our equation or function that mirrors that. Any questions? We got time to go over another one. I just, because it's with this, like I said, this is the main thing about the chapter or the section is this type of application. Anybody got any questions? I'm going to find us another one. All right, and then good thing is we're kind of staying up with the pace of the schedule, the new schedule. So hopefully we don't have to deal with any more storms. I remember like last year. I mean, we closed down 3 times. Now the one we got hit with was the last one, and that wasn't nearly as bad as what we got hit with this year. So when we get past the end of this month, I'm going to be happy. I mean, I didn't really have too much issue from the storm. I was out of my office for about a week, but what it does to other people, and plus it slows down the school. I mean, it messes it up. So let me find us another one. Anybody got any questions? Let me get us another problem here. All right. This kind of an application that let me find something where they got the data in a reasonable kind of way. Some of these have you taken it for graphs, but All right, so let's say we've got something like this. So the percentage of never married males, 62. And this is like young age. This doesn't mean ever. They got an age range. I'll check that in a second. All right. So it's not all males because it's just young males. And what it amounts to is that over the years, people are waiting longer to get married. All right, so we got 2 points here. So what I'm going to do is I'm going to just write out these 2 points. I got 33. That's right. I'm going to put in 1980. It was 33.1. And then the other point was 210. All right. So, just to let you know, is see, I'm doing this x1, y1, x2, y2. I like to do that. It kind of make sure I get everything in the right place. So then the slope is, remember, it's y2 minus y1. So that's 62.6 minus 33.1. Now just kind of notice that the way this works is why you can't mix up. These are the points right here. This was your x and that's your y. This is your x and that's your y for the points. All right. Should always happen. You can't flip those around during the process here. All right. So what do we got? If I take 62.1 and then I minus, oops, it's 62.6 minus, so that's 29.5. You might double check it for me because I'm moving quick here. And then that's the matter of years. So that's 30. So that's going to be almost 1. So it's just a little bit less than 1. And then they use the squiggle thing. So anybody knows what that means, that little squiggle thing? They had it on that over here. What was it? See, like approximately. That's what that means, in case you're wondering. Approximately. Because you have to round it off. because it's a repeating decimal. It would just be 0.983333333. So whatever they're asking it around off to, in this case, it's 100ths. That's what they're asking in this problem. So now let's build our equation. Now remember, we're going back to y minus y1 is equal to m times x minus x1. See, we're filling in this, and this, and then simplifying it. So let's see, it's y minus, I'm just going to use this one. You could use the other one if you wanted. And like I said, is the thing about applications is they're kind of not necessarily going to be nice numbers, but let's see here. So that's y minus and it's minus 1947. So when we multiply 0.93 times that 1980, we get 1947. All right, and then we're going to add this to get rid of it on the left. And when we put it over here, so that's going to be, let's see, so here we got it. And it's almost exactly, oh, wait a second. I messed up. I didn't mess up anything on there. I just, what I'm writing it down here too, so I had added, so this is 1913.9. So just watch what they ask you to round it off to. So there's our equation. That would represent how that population for married male, I'm sorry, never married males 25 through 29 has changed. It's almost a slope of 1 to 1, a little bit less than 1 to 1. So what this is useful for is once you got that equation, you can kind of predict the future, that if it continues at this pace, you know, so in other words, you can put in any other year in there and kind of find out what it would be for a given year. All right, so that's everything for today. If you got any questions, stick around.